All right, folks, it's Bass Action, back in action here. In this video, we are going to jump into bearings. Bearings tend to be the most complicated part of most of our triangle analysis. So we're gonna just get some bearing basics here, understanding how they work in general, and then as we progress through the chapter, we'll look into more complicated situations. So for starters, when we look at a bearing, an important thing to understand is that bearings are always going to be measured. It's going to be an angle between a path of travel and this vertical. It's never going to be an angle formed with the horizontal axis. So that's a really important detail to remember. When we look at this original picture that I've started off here, notice that I have this angle between the vertical and this this segment connecting to point K, but I've got a couple of these other angles between the vertical missing. So what we want to do is we want to fill those in before we get going very far. So notice that, of course, our XY axis are going to be perpendicular, so we can fill that angle up here in as 15 degrees. And we can fill in this angle right down here as 50 degrees. We want to get those filled in to remind ourselves always that those angles need to be from the vertical. Now, when we are trying to write a bearing, okay, we're going to have a direction and we're going to have a degree. Now, what you really want to focus on when you're trying to write these is look at the word from. So find the word from in whatever bearing you're asked to do and go from there. So on our first one, we want the bearing that's going to go from origin. So we're going to focus on this from. So we're going to go from origin to Z. So when we look at our picture over here, we're starting at 0, or we're starting at origin, I meant to say, and we're going to go to the direction of Z. So the first thing that we can notice is that our direction of travel is going to be to the northeast from origin to Z. So we're going to write an N and an E, and we're going to put a space in the middle because our degree is going to go in the center. So we're going from origin to Z, that's northeast, and then the angle that is between this direction of travel and the vertical is 15 degrees. So we'll put our 15 degrees in there. Now, let's go on to another one. On our next one, notice that the language on this one is a little bit different, and that's going to happen from time to time. So what we want to focus on here is, again, the word from. So now we're going to go from A. So let's find our point A, and we're going to go from A to origin, and now we can see that we're going to the northwest. So we're going to write our north and our west, and then our angle between this path of travel and the vertical is 45 degrees. Next, we're going to look at, again, we're going to look at our from. We're going to be back to going from origin. So we're going to go from origin to C. So now we're going to be going to our southwest. And our angle along our path of travel and the vertical is 50 degrees. And our last one that we're going to look at here is going to go from K. So we're going to jump to K and go towards origin. So that's going to be to the southeast. And our angle between this path of travel and the vertical is 70 degrees. Okay, so those are going to be our most basic things that we're going to look at in terms of bearings, just reading them and writing them. Now, we're going to actually have to do some trigonometry to find ours. So what I've got going on down here under our application, this is just our basic application, is we're going to look at the same scenario over and over again, and we're just going to keep changing our directions and how the distances are analyzed, and that's going to help us understand how to analyze our simple bearings. So let's take a look at our first one here. In the very first scenario, we are going to have a pilot, an aircraft, that's going to be traveling on a bearing of north 35 degrees east. We know this angle has to be from a vertical, so that's the first thing we're going to do is we're going to draw the vertical. And then we want to draw in a path of travel that goes to the northeast. So we're going to just kind of pick a spot that's going to be where they're going to take off. And we want to draw in a line that's going to kind of approximate 35 degrees, but don't spend a lot of effort to measure it. So we're going to draw in this little line. We might adjust it here in a moment, but this angle here is 35 degrees. Now, What it's telling us is that it's going to fly for 5 miles in this first direction, and then it's going to turn 90 degrees to the southeast. So we're going to go for 5 miles. I'm going to just draw it a little longer just to make my picture a little easier. Now it's going to turn 90 degrees to the southeast. Now it's telling us this new angle right here is going to be 90 degrees. Always be looking for those. The next distance is only going to be 2 miles, and although these don't have to be perfectly to scale, it is helpful. We know that the first distance was longer than the second distance, so we're going to make this segment just a little bit shorter, maybe just like half the length. So I'm going to say 2 miles right here. And then what we're going to do is we're going to connect where we're going to now measure, and we're going to connect that to our original point of origin to create a nice triangle. The goal on this problem is to figure out, did the pilot go far enough to cross this horizontal line? Now, we don't need to draw that horizontal line in quite yet. Since this triangle is a right triangle, we are able to find the measure of this angle right here inside the triangle. Simple right triangle, simple SOHCAHTOA. We can use this as our point of reference. We're going to say opposite over adjacent. So we're going to say the tangent of my angle X is 2 over 5. Now, we already know how to type this in our calculator, so we'll use our inverse tangent, and that's going to give us an angle of approximately 21.8 degrees. Now, I'm not going over that part in this video. We've done that in other videos, and you can look back to those if you're not sure how to do that in your calculator. That means that this angle right here inside the triangle is 21.8 degrees. If we want to know the new bearing, okay, from the control tower, remember that from's important, to the plane, what we want to understand is how big is this whole angle right here. If this angle is more than 90, then it means the pilot crossed over. We can see that 35 and 21.8 is not going to be more than 90, so our pilot is still traveling in the same direction that it started. It's still traveling northeast. We can add those two angles together, and we're going to get 56.8. Sometimes the problems will ask you to do it to tenths, and sometimes they'll be whole numbers. Oops, my decimal did not show up there. Okay, 56.8 to the northeast. Now what we want to do is we're going to look at a couple other scenarios. It's going to be these same numbers over and over, but we're going to mix up the directions. So the pilot's going to travel in the exact same distances. So the picture to start off is going to be really simple because it's going to start off the same. We're going to start off with our 35 degrees. And now it's going to turn to the northwest. Remember, it first went 5 miles, and then it's going to turn 2 miles. Remember, we want to make that a little bit smaller than the original length that we did. Now we're going to connect this. We've already done this trig, but I'll write it one more time. We're looking for the measure of this angle. It was a tangent X. It was 2 over 5. We already found that angle to be approximately 21.8. We don't need to redo that math. So now we're going to fill in this 21.8 here. And now what we're thinking is physically it angled off 35 degrees, and then it started to double back on its original path. Now sometimes what students like to do for this 35 is they like to draw like a bigger arc here to indicate the 35, because it's gone 35 and then started doubling back. Now we're trying to figure out, did it cross this vertical, okay? Did it cross the vertical? So then we can see that no, it only came back 21.8 degrees. So our new bearing is going to be this little amount right here that's left over. So it's going to be our 35 minus our 21.8. It's still heading in that northeast direction. It hasn't crossed to the northwest, so we're going to have now 13.2 degrees. Okay, now what we're going to do is we're going to switch up. We're going to use our same directions, but we're going to switch the distances. They're going to go now in a different order. So again, we can just start off with that vertical. You're always going to start with the vertical. This time the pilot's only going to go 2 miles to start with. still going to be 35 degrees, but now they're only going to go 2 miles to start. And when they turn that 90 degrees, oh, I just realized I forgot to draw the 90 degrees back there. When they turn the 90 degrees, now they're going to go the 5 miles. Just drawing this little bit to scale, it's pretty clear that our pilot is going to cross this horizontal, and now instead of being northeast, they're going to be going to the southeast, okay, when we're all done. So it's good to have a little bit of that idea as you jump into it. We're going to connect this. I'll put my right angle. We want to find the measure of this angle right here inside our triangle. It's still a right triangle. I can still do opposite over adjacent, but now it's going to flip. And I'm going to have tangent x, and now I'm going to have 5 over 2. So now my angle is approximately 68.2. So I'm going to go ahead and fill that in. I'm going to give myself an arrow here, 68.2. And now our new bearing is going to be from the vertical on this path of travel, and we can see that it's below the horizontal. So this angle, and this angle should all add to 180, so we can find that our new angle down here is 58.8. And our pilot is now traveling to, oops, let me erase that sometimes. We're going to the south, the southeast, 58.8. Okay, we've got one more scenario to look at here. Same vertical. Now we're going to have both the directions or the distances flipped, and they're going to turn to the northwest. So we're going to go up our 35, but this is only going to be 2 miles. This is going to be my 35. Then they're going to turn right, or turn to the northwest, and they're going to go 5 miles. And again, this is kind of clear to see when you draw these just a little bit to scale that he's going to cross that vertical. So when I connect this, we are looking for this angle right here in the triangle, okay? Put our right angle there. We're going to have our opposite over our adjacent. We just did this trigonometry. Tangent of x is 5 over 2. We already know that's going to be 68.2 from the last problem. And now, if this angle right here is 68.2, they've started off at 35 degrees, doubled back, not only their original 35, but then kept going more. So our new bearing is going to be between the vertical and this path of travel here. We can now see that they are going to the north, but they have now switched, and they're now going to the west. And our answer, this angle right here, is going to be the difference between the 68.2 and the 35 degrees, and that's going to be 33.2. These take some practice, so if this seems a little bit confusing right now, don't be surprised, because these do take some practice, but I have a lot of practice available for you, and we're going to practice these quite a bit before we plop them into some more advanced problems.